Hi. So today I'm going to show you an amazing trick where we have four difficult integrals which we'll reduce to one special class of integral. So we'll solve one integral, and that is quite interesting the way we get that. And that will give us the values of all these four integrals. So you might want to pause the video at this point and try to guess what general integral we will take here. It is not at all obvious, so I don't expect you to guess it, but you could also actually try solving these integrals on your own. You'll realize that each of them presents significant difficulties. So let's get into it. So I'll go to the next screen and I'll show you the general integral that you want to solve. So you want to do 0 to infinity dx by x power 4 plus 2x square cos 2 alpha plus 1. This is the general integral. Here alpha is a constant, right? Now if we are able to solve this integral, you can easily see that putting different values of alpha, if alpha is pi by 4 for example, right? So cos 2 alpha will become cos pi by 2, which is 0, right? This reduces this integral to this 1 plus x power 4. If alpha is pi by 3, it reduces this to cos 2 pi by 3 is minus half, so it becomes 0 to infinity dx by x power 4 minus x square plus 1. If alpha is, say, pi by 2, pi by 2 for example, right? Or you can take different values, let's say pi by 6, let's say pi by 6. If you take pi by 6, you get cos 60, which is half, so you get the third integral dx by x power 4 plus x square plus 1. And finally, if you take alpha is 0, then this becomes 0 to infinity dx by x power 4 plus 2x square plus 1. Obviously, you can get any number of integrals out of this because this just generally gives you a class of integrals dependent on the value of alpha. So I want to solve this because I want to find the answers to these four integrals easily, right? So let's think about how we will go about solving this one. The first thing that I will do here is a substitution y is equal to 1 by x. You will see why we do that. So if you do y is equal to 1 by x, so dy is equal to minus 1 by x square dx. So the integral will become, therefore this is dy into x square, which is by y square, right? 1 by y square is x square, so minus dy by y square is equal to dx. And if x tends to 0, y tends to infinity, and if x tends to infinity, y tends to 0. So this becomes infinity here and 0 here, and dx becomes minus dy by y square. And this one in the denominator, it is 1 by y power 4 plus 2 by y square cos 2 alpha plus 1. Simplifying it a little bit, you get in 0 to infinity by flipping the signs dy by y square, and you get y power 4 plus 2y square cos 2 alpha plus 1 by y power 4, right? This y power 4 will go on top, and this will become simply 0 to infinity y square dy by y power 4 plus 2y square cos 2 alpha plus 1, right? Now, notice that this integral looks exactly like this integrand, right? This integrand, at least the denominator looks exactly like it, right? And x and y are just dummy variables. So what we can do, if this is called I, this is also called I. So if we add the two, notice what happens. 2i will become what? 2i is simply 0 to infinity 1 plus y square by y power 4 plus 2y square cos 2 alpha plus 1 dy. Here you're using y as the dummy variable. Okay, so we have this situation. Now what? Now what we can notice here is that this integrand is even. It's an even function because all the powers are even powers of y, right? So for even functions, you will have this property that minus a to a fx dx is equal to 2 times 0 to a fx dx. So right now you have 0 to infinity. So 0 to infinity 2 times fx dx when it is an even function should be equal to minus infinity to infinity fx dx, right? Correct. So this part is basically half of minus infinity to infinity minus infinity to infinity 1 plus y square by y power 4 plus 2y square cos 2 alpha plus 1 dy, right? And that is 2i. So therefore, I is simply 1 by 4 of minus infinity to infinity 1 plus y square by y power 4 plus 2y square cos 2 alpha plus 1 dy, right? So you might think that we are not making any progress here, but you will see soon that once we try to factorize cos 2 alpha, you will get something much more simpler. So think about what is cos 2 alpha. Cos 2 alpha is equal to 1 minus 2 sine square alpha. If you put that in here, y power 4 plus 2y square into 1 minus 2 sine square alpha plus 1, right? So clearly we are getting y square plus 1 whole square minus 4y square sine square alpha. This and this term make the perfect square, and this is also a perfect square, so you can factorize it as y square plus 2y sine alpha plus 1 and y square minus 2y sine alpha plus 1. I hope everyone follows this step. So we are factorizing this by expanding cos 2 alpha, and we have factorized it into two factors. I'll write it on the next screen. I is equal to 1 by 4 minus infinity to infinity y square plus 1 divided by y square plus 2y sine alpha plus 1 multiplied by y square minus 2y sine alpha plus 1 dy, right? This is my integral. Now another interesting property that we can use here is that uh, this integrand, think about this integrand is also even, right? Can you convince yourself this is even? Put minus y in place of y, you will get the same thing, right? This integrand is even, and when we have minus a to a, if gx dx, if gx was odd, then this integral is 0, right? This is a standard property. So what we can do here to simplify the calculation of this integral, we can add something to it. So what do we add to it? We will add something which is 0, right? So right now I have something like this. Two I sine alpha plus 1 dy. Why don't we subtract 2y sine alpha by the same denominator plus 1 multiplied by y square minus 2y sine alpha plus 1. I'm going to subtract this integral. There is a little less space here, so I'm going to rub this off. Yeah. So what I'm doing here is I am subtracting this integral from the overall integral, right? From this integral, I'm subtracting this integral. Why is it not changing my answer? Because clearly this part is odd and this part is even. So the value of this odd by even, this will be an odd function. The value of this integral is actually 0. So subtraction should not make any difference, right? You are writing down the original integral and subtracting an integral whose value is 0. So, but that makes a huge difference for our solution, because what we can do is now combine them and write the top part as this: y square minus 2y sine alpha plus 1 divided by y square plus 2y sine alpha plus 1 and y square minus 2y sine alpha plus 1. Because I'm combining both the integrals now, And notice now this cancels one of our factors very well, right? So that is very convenient. So our answer is basically 1 by 4 of this. I'll write that in the next page. Your I is 1 by 4 of minus infinity to infinity 1 by y square plus 2y sine alpha plus 1 and dy, right? This part is easily solvable. This integral is doable because I can split 1 and I can write it as minus infinity to infinity dy by y square plus 2y sine alpha plus sine square alpha plus cos square alpha. And this becomes a perfect square. So it becomes minus infinity to infinity dy by y plus sine alpha whole square plus cos square alpha, right? And there's a 1 by 4 outside, correct? Now, this is some ax square plus a square, right? So the answer for that is 1 by a tan inverse x by a. I know the integral for this. This is a standard integral. So this becomes 1 by a is cos alpha tan inverse x by a, which is y plus sine alpha by cos alpha. This is my integral, and this is evaluated from minus infinity to infinity, and outside you have to put a 1 by 4, right? So now what we get here is when y tends to infinity, this is tan inverse infinity by cos alpha minus tan inverse minus infinity by cos alpha, right? Great. So what we get here is pi by 2 minus pi by 2. So pi by cos alpha, and outside there is a 1 by 4, right? So we get a very nice answer. It is coming as pi by 4 cos alpha. Pi by 4 cos alpha. So notice what has happened. Our initial integral, which was integral of dy by y square y power 4, or it was written in terms of x initially, 0 to infinity dx by x power 4 plus 2x square cos 2 alpha plus 1 is coming out to be pi by 4 cos alpha, right? How did we do it? Let's quickly go through the steps once more. We put y is equal to 1 by x, got another version of I, another version, and added. So we get 2i. 2i became 1 plus y square by this integral. And it was an odd function, so we made it into minus infinity to infinity and half of that. So therefore, I became 1 by 4 of minus infinity to infinity 1 plus x square, something like this, 1 plus x square by x power 4 plus x square cos 2 alpha plus 1, something like this we got. And this integral we solved by subtracting, first factorizing this into two factors and then subtracting an odd part. Once you subtract that odd part, one factor cancels, the remaining factor is easy to integrate, and we get this answer. You should revisit the steps in the video once more if you want to, if you've forgotten something, and get more clarity on it. However, this is done, and this gives us many easy results. So now put alpha is equal to 0. If alpha is equal to 0, I get the integral 0 to infinity dx by x power 4 plus 2x square plus 1, and this is equal to basically pi by 4. Put alpha is equal to pi by 2, you will get 0 to infinity dx by x power 4 minus 2x square plus 1, minus 2x square plus 1, and that will be equal to, okay, that integral is not defined because you cannot put alpha pi by 2 here. So that integral blows up, so we'll not consider that case. So let's do the other integral, which is pi by 3, suppose 0 to infinity, it becomes dx by 2 pi by 3, so it is dx by x power 4 minus x square plus 1, and that value is becoming cos pi by 3 is half, so pi by 2, right? And for alpha is equal to pi by 4, we get the integral 0 to infinity dx by x power 4 plus 1. power 4 plus 1, and it comes out to be pi root 2 by 4. That is the third answer that we needed. And finally, you can also get the integral for x power 4 plus x square plus 1 by taking the value of alpha as pi by 6. If you put alpha as pi by 6, you get integral 0 to infinity dx by x power 4 plus x square plus 1, and that comes out to be pi by 2 root 3. So that is just amazing, and especially notice the tricks that we used here. We subtracted an odd function to cancel one of the factors. So that is interesting. You should try and see if you can apply it in questions in the future as well. And that's this video. Hope you liked it. If you like the content on the channel, please like, share, and subscribe. And I'll see you next time with new problems.